Hello there, I'm Chris Knowles. I'm making the optimization puzzle game Hexahedra, and when I set up my studio, SideQuest Ninja, I spent an awful lot of time configuring a server because I wanted to have a website, a dev blog, and also an email server. And setting up an email server is quite an involved process. There are a lot of moving parts, and so I've put this video together to show you the steps I went through to get a working email server on Ubuntu 18. So we are going to set up an email server. I want to introduce you to Octavius. He's a little octopus who hangs out in our flat, and he would like to receive emails. He'd like to receive emails sent to octavius@example.com. We're going to pretend that we control that domain, and we're going to set up an email server to support all those things. Now we're going to use quite a few bits of software to do it. The main backbone is going to be Postfix, which is a mail transfer agent. We're also going to handle checking for viruses and spam and checking that emails are genuine, and for that we're going to use Amavis, ClamAV, SpamAssassin and OpenDMARC. Finally, we're going to allow for email accounts that aren't attached to Unix user accounts, and for that we're going to use dovecot, and we're going to back that up with a PostgreSQL database. So a few notes before we begin. There are some accompanying blog posts that I've written that go with this. You can find a link in the description to the first part. You might find it useful to have those open as you go so you can scroll back and forth through the text and see the commands written out. I go into a little bit more detail in one or two places in the blog post than I'm going to in the video, so there's a bit more reading if you want a bit more background. And also when we come to check for viruses and spam, there are some test strings in there that virus and spam checkers are primed to spot as being malicious, even though they're perfectly safe. But they're sort of strings of gibberish. You don't want to be typing those out by hand. So if you have the blog post open, you better paste them into an email to send yourself. Another warning before we kick off, please do not just blindly follow my lead. Information on the internet goes out of date. You know, the state of mail service changes. Please don't just paste in every command I give you here into a server to get it up and running. Do your own reading, make sure that what I'm telling you is still true when you come to watch the video. On that note, this video is designed to work with Ubuntu 18.04 LTS. It would work pretty much the same way with any Debian-based distribution, but if you're using a different distro, then you may have to vary things a little bit more, but the core principle is the same. Finally, one note about ClamAV, which is the virus scanner we're going to use. It is going to use about 1 GB of RAM when it's running because it loads all its virus definitions into memory. So do make sure that you've got enough memory available on your server for this to work. And by the way, if you're worried about Ubuntu's approach to open source software and the way that it promotes some stuff that isn't quite free or isn't quite open source, all the software we're going to use comes from the main and universe repositories, which are entirely free and open source. So really, for this to work, there are 4 things we need to do. First of all, we need to tell people that we have a mail server so they know where to find it so they can in fact send us some email. We then need some software running that is going to handle incoming connections from mail servers on the internet and receive emails and deliver them to a mailbox. Thirdly, we need the reverse. We need to be able to submit an email to our mail server for it to send out to somebody else. And finally, we're going to need to be prepared to defend ourselves from bad people on the internet. Of which there are quite a few, and as soon as we have a mail server, people are going to want to send us viruses, they're going to want to send us spam, they're going to try and hijack the server to send other people viruses and spam, and so we're going to use various things, SpamAssassin, ClamAV, and so on, to deal with that. So before we get round to actually installing any software, we're going to need to tell people where our mail server is. We do that with a DNS record. It's called an MX record, a mail exchanger record. You'll need to go and set one of those up with the points to whatever you want your server to be. So if you want mail sent to example.com to be handled by a server called mail.example.com, that needs to go in an MX record. Now you have to set that up in whatever way your hosting provider lets you change DNS records. You'll notice that MX records have a priority value if you want to go and set one up. Now slightly confusingly, the lower the priority value, the higher the priority of the server. But if you just have one, then you don't really need to worry about what that value is. A default value of say 10 will do absolutely fine. Once that's done, we need to make sure that Postfix is able to tell that it's meant to be handling mail sent to mail.example.com, and we do that using the server's hostname property, which is just its idea of its own name. So if you just run the hostname command from the command line, you'll find out what your server thinks it's called. And that is not the fully qualified domain name that you put in the MX record that any other server can use to find your server across the open internet. We're going to need to change it. Now setting the hostname is very simple in Ubuntu. It's just set by the contents of a file at etc/hostname. So have a look in there with a text editor and set the value to whatever you put in your MX record. Now, Ubuntu reads that text file on startup to set the hostname. So what that doesn't do is it doesn't change the hostname right now. If you run the hostname command again, you'll find that it hasn't changed. So if you want to change it now without having to restart the server, then just run the hostname command with the hostname you want as an argument, and that will set it until restart. But of course, at restart, it will read the value from the file and will be away. Okay, we now want to install Postfix. I'm going to recommend that you get the latest stable version available for your distribution. That might mean going and adding the updates repository or the backports repository for your particular version. So for Ubuntu 18, rather than Bionic, you might want to use Bionic Updates, which will have slightly later versions. If you're using Debian, then you might want to use the backports repository, and so on. This is going to be particularly important for Amavis. The version of Amavis that is in the Bionic repository for Ubuntu 18 has a bug in it, which is going to, well, I'll come on to it later when we get to that point, but the version in the Bionic Updates repository has the patch applied that fixes that bug, and so it is worth doing, getting the latest version. So install Postfix like this. That will probably want to grab a whole load of dependencies, so let that run. But Postfix itself runs as a series of small daemon processes, so it's very modular, it's broken up, which is quite handy because if one process goes wrong, it can just be killed and restarted. And you configure Postfix by telling it which daemons, which services you want it to run. Now there is a command line tool called postconf that lets you set values in the Postfix config, but we're going to be making a lot of changes, and I'm going to recommend you just open up the text files directly and edit them there. And under Ubuntu, you can find the file that controls which services are running in etc postfix master.cf. So open that up and we'll take a look. So you'll find a lot of it is commented out. That's the line starting with hashes, but those comments do often contain sensible defaults that you might want to use if you turn those services on. By the way, there is another set of files in user share Postfix, which contains the default files unchanged. So if you do manage to get your config files messed up, you can go and look in there, find out what the defaults were, and that might help to dig you out of a hole. First of all, you want an SMTP daemon. SMTP is the simple mail transfer protocol. It's how emails are transferred between mail servers. It's also how we'll submit emails to our mail server to send them out. So generally, sending email happens on two ports. So port 25 is the default port for mail servers sending information between each other. But when we want to submit an email, we use what is known as the submission port, which by standard is number 587. So we're going to set up the SMTP daemon to listen on both of those ports, one to listen for incoming emails from other mail servers, and one for when we want to send emails out. So let's have a dig into here and see what these things do. So the first line of this SMTP is just an alias for port 25. So by doing this, Postfix is listening on the correct port automatically. So the service type is set to iNet, which means that it is listening on a TCP/IP socket, so it can potentially be reached from the outside world, and that's what we want, so people can send us emails. Similarly, you'll see we've set private to no, again, so it can be reached from outside. Unpriv, the fact that it's a dash there means it's using the default value, which you can see is yes. That's good because the SMTP daemon doesn't need root privileges, and we don't want to give them to it if it doesn't need them. We can go one further than that by setting chroot to yes. We are locking down the daemon so it can only access one tiny part of our file system, which specifically is the mail queue folder. We leave wake up set to never, so some of the services that Postfix runs are run periodically, that is poked every now and then. We only want the SMTP daemon to run if there's actually an email coming in, so we never need to do anything on wake up. We leave max proc to the default of 100. That's the number of instances of the daemon that Postfix is willing to spin up to handle incoming emails. And the final column, command plus args, tells Postfix what to actually invoke when an email comes in. You can see it's set to SMTPD, which is the SMTP daemon process. So that's already uncommented. Postfix is listening on port 25 for incoming emails. However, it isn't going to know what to do with them when they arrive. By the way, this is now a good time to talk about firewalls while we're talking about ports. Hopefully you have a firewall set up on your server already. If you don't, then seriously, pause this video, go away, sort that out. That is an important line of defense against bad people on the internet. For email, you're going to need 3 ports open, port 25 and port 587 as we discussed. We are later going to use port 993 for IMAP. That's how your mail client on your PC, whether it be Thunderbird or whatever, is going to connect to the mail server to receive emails that have come in for you. So with that aside, we'll go back to Postfix. So what isn't working by default is a service listening on the submission port 587. But there is a commented out version of that, so scroll down to find that, uncomment out the submission line, and either add or uncomment the following lines to get it set up and running. By the way, you'll notice that a lot of these lines start with -O. That means they are overrides, so they are overriding the values of those parameters as set in main.cf. And also you'll notice that it has 2 trailing spaces in front of each -o line. Make sure you leave those there, otherwise Postfix is going to read those lines as the start of new service definitions and it's going to get very confused. So the first line is identical to the SMTP service we already looked at, except that it starts with submission, and again that's an alias that points to the to port 587. We'll just run through these overrides so you know what they do. So syslog name is just for logging purposes. Logs that are triggered by this service will use whatever you put here as a prefix, and postfix/submission is pretty clear. I would just leave that as it is. SMTPD TLS wrapper mode is to do with TLS encryption when clients connect, when mail clients connect like Thunderbird. We'll talk about encryption later, but you want to set that to no because that will disable a legacy version of doing encryption that we don't want to support. So SMTPD TLS security level equals encrypt tells Postfix we want it to refuse to talk to any mail client that isn't using encryption. We're going to need to set up an SSL certificate. We'll do that later. And SMTPD SASL auth enable yes enables SASL authentication. So that means that when a mail client wants to connect to send an email, it's going to have to supply a valid username and password. So if Octavius wants to send an email from his computer, he's going to need a username and password to do that. That's a different benefit from the encryption one. The encryption one ensures that the email can't be read or altered between your computer and the mail server. But the username and password means that, you know, when Octavius rocks up and claims to be Octavius, Postfix can be sure that it really is him. The next line is pretty long. SMTPD relay restrictions. That has 3 values in it: permit my networks, permit SASL authenticated, and defer. And this tells Postfix when it should be willing to relay a message, which means send it on to a different mail server. So you don't want to relay any old message. That would make you an open relay. That would mean that spammers could send emails to your server to forward on to someone else, and you'll get the blame for spamming lots and lots of people. So the list of options controls what Postfix does, and it evaluates them from left to right. So first of all, we have permit my networks. So you can give Postfix a list of IP addresses, and it will always be willing to forward on emails coming from those IP addresses. Now, by default in Postfix 3.0 and later, and that is just the local machine. So this means that Postfix will accept any email that is generated locally. And if an email passes that test, Postfix doesn't bother checking the rest of the arguments because it knows it can forward the email. So if that test fails, it'll look on to the next one, which is permit SASL authenticated, and that means that it will be willing to relay any email that comes from someone who's managed to authenticate with the username and password. So if Octavius successfully is able to log in via his mail client, he will be able to send emails out into the world. So the last option is defer. That tells Postfix what to do as a last resort. Defer means that it will reject the email, but it will send a response back to the sender saying that it is allowed to try to send the email again later. There's also reject, which again rejects the email, but sends a message back to the calling web server saying, please never ever ever send me this email ever again. Now we need to give Postfix some sort of sensible fallback position for any mail that gets to this point, that gets to the last option. If there isn't any kind of sensible fallback like defer or reject, or we'll see one later called defer unauth destination, then Postfix will actually refuse to handle mail because it knows there'll be some cases where it won't know what to do with an email when it arrives. Now you might have realised that the default SMTP daemon that was already working doesn't have any overrides at all, so it is just reading the values set in main.cf. So we'll go over there and we'll have a look. Now the options here for the SMTP service should be what we want. You should find that SMTPD relay restrictions in main.cf, which is the default version, is set to permit my networks, permit SASL authenticated, defer unauth destination. And so the first 2 arguments are the same, the last one is different. That means that Postfix will process an incoming mail if it's not generated locally and if it wasn't sent by someone who was able to authenticate, if and only if it realizes that it is an email it needs to deliver locally. It's an email that is going to stop here. It's not going to be sent on somewhere else. And that means that anybody on the internet can send Octavius an email, but they can't use a web server to send an email on to someone else. We're not an open relay. We can't be hijacked by spammers. Now there are some things we want to change in main.cf. First of all, we need to tell Postfix that it is meant to handle mail sent to whatever we set the MX record and the hostname to. So first of all, we want to set the myHostname parameter. So set that to whatever the hostname is. We then also need to set myDestination, which tells Postfix it should accept mail for the listed domains and deliver them to local mailboxes. We want to set a few things in here. We want to set it to this. So myHostname, local.mydomain, and mydomain. You'll notice that when we're referring to one config variable within another, we put a $$ on the front to show that it should read the variable and it's not just a string that contains the characters myHostname. And with these settings, incoming mail should be handled correctly whether or not it was generated from another mail server or whether it was created locally. You might notice that my domain itself isn't actually defined anywhere in this file, but by default it is the same as my hostname, but with the first section taken off. So if my hostname is mail.example.com, my domain by default is just example.com, which is what we want. Now, once you've set my destination, the defer unauth destination setting for the SMTP daemon will reject any mail unless it's addressed to @example.com, @mail.example.com, or unless it was generated locally. Now we also need to change a few settings in here to do with outgoing mail. Now when Octavius sends an email, we want that email to appear to come from octavius@example.com, but there are various situations where that might not happen. If he's using just a local mail client on the box, it's possible that his emails might appear to just come from Octavius with no domain information at all. It's also possible they might go out into the world from octavius@mail.example.com, which we don't really want either, and we can fix both of those things here. So first of all, we'll deal with mail that appears to just come from Octavius with no domain information at all. Now by default, when Postfix sees an email without any domain information, it will attempt to append something. You can turn that off, but I don't recommend it. But what it appends is set by the my origin setting. Now by default, that is set to my hostname, which isn't what we want. We don't want the emails to come from octavius@mail.example.com. So instead, we can change my origin to be my domain, and that will give us octavius@example.com. Now if you're in the second boat, which you might be depending on how things are set up, and you find that no matter what you do, you're sending emails from octavius@mail.example.com and you can't get rid of the mail bit, we need to set the masquerade domains property, and we need to set it like this to my domain, and that will strip, mail.something.something.else.example.com down to just example.com. So it'll strip out the mail in mailexample.com and get us the domain information that we want. Now, in theory, we have now done everything we need to send email out into the world in a very basic way, but we do need to get Postfix to reload its config to spot all the changes, and we can use that using init.d like this. So send the reload command, and then you can try sending an email to an external email address using the mail command. Now, if you haven't got that installed, you can just install mail utils, and that will add that for you. And then if you wanted to send an email out to, I don't know, octavius@gmail.com or something, you'd use the mail command with the email address as an argument like this. You then need to fill in the various parts of the email and press Ctrl-D once you've finished adding the body, and the email will send. Now, there'll be an awful lot of logging produced by this. You can look in var log mail.log. Postfix will put all its logging information in there. Now, if you go and open that up, you'll see an awful lot of lines that look a bit like this. Now this is someone trying to connect to your server to send spam. This is, once again, bad people on the internet. This is some script that is trying to connect to your server to see if it can get access to send emails on to somewhere else. You'll see the auth bit there tells it it's been asked to provide some credentials. It can't do that, and so it's gone on somewhere else. However, if you scroll down somewhere at the bottom, you should hopefully see some logging connected to you sending an email out into the world. And if there are any problems, these logs might help you diagnose what's going on. Now, if you find that everything in here seems to be fine, but emails aren't arriving on the other end and they're not even being flagged as spam or something, you might want to skip on to a later part of the video. I'll put the time index at the bottom. There is a possibility that you need to go and set a PTR DNS record so that you pass a reverse DNS lookup. It's possible if you failed that check that your emails are just being discarded out of hand. Now, because we are listening on port 25 for incoming mail, you should be able to receive mail as well. So if you reply to the email you sent out to yourself to send one back, and then run the mail command with no arguments, you'll see if an email arrives. If you run the mail command before any mail arrives, you'll see an error saying that your mail directory doesn't exist. It doesn't actually get created until some mail turns up. But once some mail arrives, that should start working. So all being well, you can now send and receive emails in a very basic way, but they are being sent in the clear. They're being sent in plain text. This is not good. What we want is, as much as possible, for our emails to be sent over encrypted TLS connections. Now, there's one rather disturbing thing about email, which is that we can't force that to happen. We cannot require that another mail server that we talk to send a mail or to receive mail from supports TLS. So it is possible that your emails will be sent out into the world over an unencrypted connection. Now, you may have noticed before, when we were doing the submission port stuff, we were enforcing encryption. We were saying that if we wanted to send an email from our computer to the mail server, we were going to require it be encrypted. That's easy to do because mail clients support that. It might sound slightly bonkers that you can't, require that another mail server accept an email over TLS, and you'd be right. It is pretty nuts, but that is just the state of email, I'm afraid. Email is not a secure means of communication. Now, big reputable handlers will do this. If you send an email to Gmail or to Hotmail or something, you'll see a load of headers when it arrives that show that it was handled, at least internally, over TLS connections. And do bear in mind as well that even if your email is being sent on each hop over a TLS connection, that's not end-to-end encryption. It will be decrypted in the middle and readable on any server that it passes through. Still, it is worth setting up encryption where we can. As I say, the big email providers will support it, so we'll do that now. Now, to work with encryption, you're going to need an SSL certificate that other servers will trust. I'm going to recommend you get one from Let's Encrypt. There's a link at the bottom. They will provide you an SSL certificate that anyone will trust for free. I'm not going to go through how to set that up, but if you go to their website, you'll find all the information you need to get a certificate and set up your server so that it renews automatically. Now, once you've got your certs, you need to tell Postfix about them. Again, look in main.cf, and you'll find actually there are a couple of lines that are using a couple of fake certificates that are generated by default. And you want to change those lines to point to your certificate. So if you're using Let's Encrypt, you'll need to change them to something like this. You might also want to generate your own Diffie-Hellman key. I'm not going to go into the details of why. Again, I'll put a link in the video to show you why you might want to do that. But if you do that, then you can set that in a setting here, SMTPD TLS DH1024 param file. Don't worry that the name has 1024 in it. It will support 2048-bit keys if you want to. Oddly enough, you might also find in here, as I did, that Ubuntu is using an obsolete postfix setting in its main.cf. So mine was using SMTPD use TLS equals yes. That's been retired. What you want to use instead is SMTPD TLS security level equals may. And the may, rather than encrypt, rather than enforcing it, is what I was saying before. We can't require that other mail servers we might talk to support TLS, but we do want to use it when we can. Now, SMTPD TLS security level equals may means that we will be willing to receive emails over a TLS connection. We also want to try and send them over TLS as well. And so there's another setting, just one letter different, SMTP TLS security level equals may. And that's the setting that Postfix uses when it is the client, when it is the thing sending the email out. Now, we should check this is working. You can add some logging to Postfix, so it'll spit out a lot of TLS stuff. The variable for that is SMTP TLS log level equals 1. That'll put a load of stuff into var log mail.log. You can also send an email out to somewhere like Gmail, check the headers when they arrive, and you should see the emails were sent over TLS. But there's also a bit easier web services you can use to do this. I use one called checktls.com. You go there, you give them an email address at your domain. The actual email address doesn't actually need to exist. They just use the email address information to talk to your mail server. And it will then run through and go through the steps of trying to establish a TLS connection and see if it's working. And you'll get an output a bit like this. You can see all the steps it goes through. You can see that it verified the certificate chain. And if there's anything wrong, this should give you some useful output in tracking that down. So all being well, we can now send and receive the email in a very basic way, and we can send it encrypted where possible over TLS. Great. Okay, so now that the basics of the email is working, we need to deal with all the malicious stuff that's going to come in. We need to deal with all the viruses and spam. We're going to use Amavis, SpamAssassin, and ClamAV for this. And we're going to set these up as mail filters. Now, you may occasionally hear these referred to as milters as well. So Amavis is going to act as the interface between our mail transfer agent, which is Postfix, and SpamAssassin and ClamAV. So we're going to get Postfix to pass emails to Amavis. It will then take care of doing all the checks, and it will then pass them back to Postfix to be delivered. Assuming all is well, then the mail will just be passed back as it was, but it might have had some headers added to flag it as spam or something like that, and actually potentially it may be thrown away completely. So we're going to install all the packages we need for this now. This is where I come back to saying that you may need to make sure you're using the Bionic updates repository on Ubuntu 18 rather than just Bionic. So the version of Amavis dnew that's in the Bionic repository, it has this version number. This has a bug in it to do with the originating flag. I'll cover that later. You want a version which is no older than this. And the Bionic updates repository does have a late enough version to get around that bug. So you want to install the following things. That will want to install some dependencies. It'll also want to use up quite a lot of disk space because ClamAV is going to download a lot of virus definitions. So just let that run, but it'll probably take a while. So first of all, let's set up Amavis to use ClamAV as its virus scanner. Now on Ubuntu, the Amavis configs are spread around a folder called etc amavisconf.d. In other distributions, you might end up with just one enormous config file, but I'm going to assume you're going to be using the split up version. So head over to etc amavisconf.d 15-AV scanners. And you should see a lot of config options for different various virus scanners, but hopefully you'll see that ClamAV is at the top, and in fact it's already uncommented because it's the sort of the standard default. Now, an Amavis config file is generally not pretty, as you can see, but notice those comments underneath. We're going to have to take note of those. A bunch of users and groups will have been added by the installation of the software, but we're going to need to add the ClamAV user to the Amavis group. That's very straightforward. We just do this. You can ignore the bit about adding allow supplementary groups to clamd.conf. That's been deprecated. You notice it's telling us to edit some stuff to do with sockets as well. The file we need is etc clamd.conf. Head in there, set the local socket value to whatever was in the Amavis config, which in this case was var run clamav clamd.ctl. Now happily we don't need to tell Amavis about SpamAssassin because Amavis is built using the SpamAssassin libraries, and in fact it'll be set up pretty much automatically to do spam checking for us. Now, as time goes on, once you're up and running, you might find you want to tweak the SpamAssassin config settings to change how aggressive it is and what it considers spam and not, but for now we'll just leave things as they are. So Amavis is now set up to use ClamAV for virus scanning and SpamAssassin for spam, but it isn't actually going to be doing any scanning at all at the moment. We need to go to another text file. We need to go to 15-content filter mode. There are two settings here. Slightly confusingly, we need to uncomment two variables called bypass virus checks maps and bypass spam checks maps. And certainly in my file there was an enormous comment saying yes really you do need to uncomment these to turn it on. Now what these variables do is they tell Amavis to check in the variables contained within them for cases where we shouldn't check for viruses and where we shouldn't check for spam. But these variables don't actually exist, they're not defined, and so they're just empty. And so by uncommenting these, we are telling Amavis to turn on virus and spam checking, but actually there's nothing that it shouldn't check, and it will check absolutely everything. Amavis also needs to know what the hostname is, and it should actually be set up to grab that automatically. So have a look in yet another file, 05 node ID. Now you should see a line that will grab the hostname and set it in the config, like this. If you need to set it manually for some reason, there is a commented out line below, but this is doing what we want, so we can just leave that as it is. However, we also need to tell Amavis what domains it should consider local, because email that is coming in is treated differently to mail going out, and that isn't going to be set correctly by default. So head over to 05 domain ID, and you'll see a similar thing that is trying to automatically set the name. Now this one isn't quite right. It's going to be looking in Etsy mail name, and by default that is going to be mail.example.com, but we want it to just be example.com, so we can change that. Now if I'm going to override this and use a manual setting, we can actually put that in a different file. We can go and find the file 50-user. Now the way these config files work is that a file that starts with a higher number, so 50 user rather than 05 domain ID, will override a setting in a lower numbered file. So here we can just set the local domains ACL manually to example.com. Finally, we're going to tell Amavis how many emails it should process at once. It'll spin up as many daemons as it needs, but frankly 2 will be enough. We're going to set up some corresponding variables in Postfix later to make sure these line up. But you want to set 2 things in 50-user. We want to set max servers to 2 and max requests to 20. And max requests there controls how many messages Amavis will handle on a given process before it tears down that process and starts up another one. And you could set it to 1 and get a new process every time, but that creates some overhead. So we can now give Amavis a restart because we've changed its config, and we can also just check exactly what it's doing and whether it's picked up ClamAV. So run the following. You should get some output like this. So you'll see that it has picked up ClamAV as a scanner, and it's even got a fallback, a non-demonized scanner if it needs it. You might get some notices that say something like, oh, there's no decoder for LZ4 or something like that. And what that means is that Amavis doesn't know how to unpack an LZ4 file, so it isn't able to unpack it and scan it for viruses when it comes in. So if you want to enable that, you can install the relevant utilities on your box, and that will give extra capabilities to Amavis. We also want to check that Amavis and ClamAV are set up to run as services that will run on startup. We can use system control for that like this. Hopefully you'll see a few Amavis things. The main one is amavis.service. You should see 2 ClamAV ones. So ClamAV-daemon is the actual daemon process that scans for viruses, and ClamAV-freshclam is what gets new virus definitions to keep everything up to date. By the way, you can also look in var log ClamAV freshclam.log to see if that's working. Now again, because Amavis is built using the SpamAssassin libraries, you don't need a separate SpamAssassin daemon these days, and that will be happening automatically. You might find something's missing. I actually had to start up the ClamAV daemon manually, so here's the command for that. You also want to check that Amavis is getting SpamAssassin updates. That's done with a cron job. So if you have a look in etc cron d amavis d-new, you should see this. And this is going to take care of keeping SpamAssassin up to date for us. So now Postfix is running and Amavis is running, but they don't know about each other. So the first thing we're going to do is we're going to tell Postfix to forward incoming mail to Amavis. Now by default, Amavis will be waiting to process messages by listening on port 10,024. We didn't change anything there, so that's the default. You can check that out just by running netstat like this, and you'll get the following. So we need to tell Postfix to send emails to that socket so that Amavis will pick them up and process them. And we're going to add a new service to do this. So go back into master.cf and add this. So we're calling our new service lmtp-amavis. It's listening on a Unix socket. We're not actually going to use that. We're going to use a different system to get Postfix to pass the emails on. Got a max proc of 2. That lines up with the max service thing we set in Amavis before. And finally, we're telling Postfix this is an LMTP service. Now, LMTP is the local mail transfer protocol, which is a little bit different to the simple mail transfer protocol. Doing that has some advantages when it comes to reporting back if anything goes wrong. I'm not going to go into details there, but we save ourselves a little bit of overhead over using SMTP. We set a few arguments here. So LMTP data done timeout. That sets a time limit, which is in seconds, so that's 20 minutes. That's how long Postfix will wait for the email to be processed. If the email isn't delivered within that time, Postfix will give up and will send a message back to the sender saying, sorry, I couldn't deliver this for you. The default is 600 seconds, that's 10 minutes. That's already pretty pessimistic, but we've added a bunch of things in, like virus scanning, so we're upping that just to be even more pessimistic. LMTP send x forward command equals yes. That means that Amavis receives some headers from the original email, like the original sender's IP address. It can use those for some extra checks to try to see whether or not the email is legit. And max use equals 20. That's the same as the max requests value we put on the Amavis config end, so that those line up. So we need to tell Postfix that this is the service it should use to check mails. So we're going to go back into main.cf and set the content filter parameter. Here we go. So this is telling Postfix that the LMTP Amavis service is where to send the mail to be filtered, and it should get in touch on localhost and on port 10,024. So now we have a path for the emails to get to Amavis, but we now need a return path. We need a way for Amavis to resubmit the emails to Postfix. Now we can't use the normal SMTP or resubmission ports because the email that arrives on those ports is sent to Amavis, and if we do that, we'll end up in a loop and our mails will never ever be delivered. So we now need a reinjection service that we can use, which will bypass all those checks. But if we're going to have one of those, we want to make sure that we can only send emails to it from trusted sources, like something coming back out of Amavis. So go back to master.cf. We're going to add quite a chunky service here. We're going to add this. And as you can see, actually here, we are mostly turning things off. We're using a load of overrides that set various settings to the empty string so they don't do anything. We turn off the content filter. That means that emails arriving here won't go back into Amavis. That's what we want. The next 3 lines are what keeps anybody in the outside world from sending emails to this service. So we set my networks to 127.0.0.0/8, so only local connections are accepted. And then we set SMTP client restrictions and SMTPD recipient restrictions to permit my networks and reject. So only things on my networks will go through, everything else is told to go away, and this is nice and secure. Now by default, Amavis is going to use localhost and port 10,025 to resubmit, so we don't need to do anything on the Amavis end. This is where the emails will end up automatically. So at this point we can reload Postfix's config and we should have virus and spam protection. And one way to check this is all working is we can actually talk to these new services on these new ports by hand using telnet and see what they say. So you can telnet to the Amavis side with this by talking to port 10,024. You should get some output from Amavis d-new with a 220 response code, and if that's all fine, you can ask it what services it supports by using the LO verb. And you should get a load of things back, all starting with a code of 250. And if that happens, then everything is working fine. We can do a similar thing on the Postfix end. We can telnet into 10,025. We can do the same thing here. You're looking for initial response code of 220, and the LO verb should respond with a load of 250s. Now we want to test the entire thing end to end. We want to test that we really are filtering out viruses and spam. And obviously we want to be able to check that we are filtering out viruses without actually emailing ourselves a virus. Thankfully we can do that. There's a thing called the iCard test signature, which I'm going to put at the bottom, but I'm going to recommend you get it out of the blog post. The link is in the description. You can then paste that in. This is an entirely harmless string, there's nothing malicious about it, but virus checkers are programmed to treat it as if it was a virus, so you can check that they are working. So if you send an email to your new mail server with this in the body, it should get filtered out as a virus. Now you might find actually sending this email is quite tricky. So when I tried to do it from my PC, from Thunderbird, Windows actually blocked the email and said, I'm not going to send this, it's got a virus in it. But I was able to send it from my old Hotmail account. So thanks Microsoft, I guess. But send that through, check the logs, and you should see in your mail log something a little bit like this. There you go, boom, we have blocked the virus, which means that Postfix and Amavis and ClamAV are all working together and handling our virus emails correctly. We also want to do the same for spam. There is a similar test signature you can send in the body of an email, which should get filtered out as spam. So again, that's in the blog post, but I'll put it here just for the sake of it. And if you send that in the body of an email and look in the mail log, you should see something a bit like this. There you are, we have blocked some spam. Now one thing to note is that we are actually sending all email to Amavis, whether or not it's actually coming from an external mail server or whether it's coming from the submission port, which means actually we are checking outgoing mail for viruses and spam as well. So if you were to get a virus or if something were to compromise your computer and start trying to send out spam, these things will hopefully catch that before they go out. Okay, so emails are now coming in and going out perfectly fine. They're even being scanned to see if they have anything malicious in them. But currently this is all rather inconvenient. We're using the command line to send stuff. We'd much rather be using something, some sort of mail client, something like Thunderbird, to send and receive in a much nicer way. However, there is a step we need to take before we can do that, which is that currently mail accounts are tied to Unix user accounts. Someone needs an account on your server in order to have a mailbox to receive email. So Postfix has a virtual mailbox system that we're going to make use of. We're going to get it to deliver mail to a bunch of folders, all owned by one user we're going to create. We're going to call it Mail Reader. We're going to need some way to tell Postfix, which folder within there to put things in, and we're going to set up a database to do that running on Postgres. So we're going to create a system in there where we can add users who can receive mail. We're going to give them a username and password as well, and we'll use that later with Dovecot for the SASL authentication stuff we've been talking about. And we're going to put some other routing information for Postfix in there as well. So we're going to create our new user, and that user will also have its own group, and we're going to need the numeric IDs, the UID and the GID, later. Now adding the new group is very easy. We just use the group add command, and then we can grep the group's file to get the GID. So in my case that came out as 1002, but just take note of whatever it is in your case. And then we're going to create the user and assign it to the group, and set up a few other things while we're there. So we want to use the following for that. So the argument on the end just tells us that we're creating a user called MailReader. The -G puts it in the MailReader group. -D tells us where its home directory is. And the s/sbin/no-login sets the user's shell, and the no-login shell just prints out a polite message saying you can't use this user and then quits. And so that stops anyone logging in as this user and using it because we don't need it to have that kind of access. And again, that grep command will spit out the UID for the new mail reader user. So again, write that down. In my case, it was 1002. There's no guarantee it will be the same as the GID, but just write down whatever it is. Now the home/mail directory won't actually exist. We'll create that by hand and we'll assign it to the mail reader group and user, like so. So now we need a database. Now for a small scale solution like this, which database you use isn't actually terribly important. You could use MySQL, although most Linux distros have moved to something called MariaDB, which was a fork. I'm going to use PostgreSQL just because I'm more familiar with it. At scale, Postgres would generally work slightly better. It doesn't really matter too much at this point, but yeah, just go with whichever you're comfortable with. So we're going to install Postgres, and we're also going to grab Postgres support for Postfix, which we'll need in a moment. Okay, so on Ubuntu 18.04 LTS, this is going to install Postgres 10. Now, major releases of Postgres happen every once a year or so. In fact, Postgres 12 is now out, but the major releases are supported for 5 years, and so Postgres 10 support will carry on until November 2022, so that should be fine for now. Once the installation is run, Postgres should set itself up to run as a service. Now we're just going to do a few things to secure up the Postgres installation slightly. So as well as adding a Unix user called Postgres, Postgres itself has its own internal users, and there is one called Postgres there, which is a super user that can do anything. And we're going to leave that mostly alone, but we are going to change some settings for what other people can do with our databases. Now the file we want to edit for that is pg_hba.conf. And where that's going to hang out is going to depend slightly on what version you have, but in my case, etc PostgreSQL 10 main. So there's a helpful comment line here that tells us what all the different columns of these settings mean. So the peer authentication method, you can see that under Postgres, just tells us that the Postgres Unix user can log in automatically as the PostgreSQL user. Now the Postgres Unix user needs some non-interactive, so no password or anything. It needs that kind of access to the database in order to do various maintenance tasks. We don't want to make that any more complicated. But the lines underneath, we can get rid of those to make things a little bit more secure. So currently any user can connect to any database using that peer authentication if they're on the local box. That's not really necessary. And they can also use, if they have a password, they can connect to every TCP/IP connection. And again, we don't want to use that. This is only for Postfix's benefit. Now that MD5 bit means that the password is hashed using the MD5 algorithm. That's not a very good password hashing algorithm. That's not what it was designed for. Now given that we're going to lock everything down to only work locally, this isn't the end of the world. We could use something called SPAM-SHA-256. Unfortunately dovecot doesn't support it, so we can't. But when it comes to the actual passwords for our users, which aren't going to be configured in this file, they're going to be stored in the database, we are going to use a much better password hashing algorithm than that. What we are going to do here is we're going to lock things down a bit. We're going to remove those 3 lines allowing anyone to log in. The replication stuff at the bottom, leave that alone. But we're going to take those 3 lines out, and then we're going to add some new lines for some specific Postgres users that we're going to create. So we're going to create 1 new database, and we're going to create 2 new users. We're going to create 1 user called mailreader. This is a Postgres user. It's different from the Unix user we created before. And we're going to have 1 called mailreader_admin. And we're going to give much more privileges to the admin user than the mailreader user. So mailreader is what we're going to use with Postfix and dovecot to read from the database, see what email accounts are there and that kind of thing. The mailreader admin user is what we're going to use to set stuff up. The reason we want 2 is that unfortunately we're going to have to put the password for the mailreader user in a text file so that Postfix and dovecot can look at it. We don't want a user that has access to delete things from the database and delete the database entirely and so on. We don't want that password just stored on the machine somewhere. Anyone who does get access to the mailreader password in a plain text file will be able to look in the database, and they'll be able to find the hashed passwords for our mail users, which isn't great, but there's not much we can do about that, and we are talking about someone already having compromised the machine and got access to it. So we're going to comment out those permissive default settings, and we're going to add the following. So again, all we can use here is the MD5 password algorithm, which isn't great, but this is just for the initial login. This isn't storing the passwords of our email users. So this sets things up so that Postfix and dovecot connect to the database over TCP/IP on a local connection. And we're going to use mail server admin over PSQL, which is Postgres' command line interface, to actually set the database up. So you need to save and exit that file, and then we're going to get Postgres to reload its config to make that work. Okay, we then want to connect to the Postgres server just as the Postgres user for now. We're using that peer authentication method we talked about before. You can do that with this. Now that we're here, we need to create some stuff. I'm going to give all the SQL statements on the screen here, but again, they're in the blog post. You might want to grab those. Do also note that the SQL lines are going to finish with semicolons. So first of all, we'll create ourselves the mailreader user, and then we'll set its password. Now that /password command will ask you to enter a password, and now you could do this with an SQL statement. You could run create user mailreader with password, some password. The problem with that is going to put that password in plain text in your command history. You can just keep pressing up on the keyboard till you get back to that command and you can read what the password is. This actually is another reason to use Postgres over MySQL or MariaDB because they don't have a way around that problem at the moment. One thing to notice about your password, by the way, is that dovecot doesn't support a particularly large character set for passwords. Once we've installed dovecot, you better go and look in the config file for what that is, but the default of my installation was this. Now they've used a reduced character set for a reason. I'm not sure they meant to include 0 twice, but there we are. But those are most likely the characters you can use in your password for the mailreader user. For everything else, though, feel free to go to town. Use less common characters if you want to, and certainly you can do that for your email account holders. So we're now going to create the mailreader admin user and set the password in the same way, and then we can create a database owned by that user. So here we go. So Postgres database has a nice hierarchical structure. So a database has one or more schemas, and a schema can contain one or more tables, and that's where the data actually goes. And by default, there is a public schema, and by default, anybody can create things in the public schema. We want to change that. We don't want any old Postgres user being able to fiddle around with our database. So we're going to switch to looking at the mail database, and we're going to turn all that stuff off. We're going to turn it back on for the mailreader admin user. So you can see we are revoking a bunch of privileges from public, which just means referring to everyone, and we're going to grant them back to the mail reader admin user. You might also notice that we are assigning ownership of the public schema to mail reader admin. By default, the public schema of any database, even if it's owned by a different user, is always the Postgres super user. So we're going to assign that to mail reader admin so that it has the privileges to change things about the schema as well. That doesn't stop the Postgres super user from making changes as well, because it's the super user, it can do anything, but we do now have the privileges to do that with our admin user. So we now want to connect to our new database as the mail reader admin user and set some stuff up. You can quit PSQL with /q and then you can reconnect as the new user. And here now we're going to use a username and password rather than the peer authentication method. So first thing we want to do is create a table that's going to allow us to add new email users that aren't tied to Unix users. So we need to create a table like this. We'll call it users. It's indexed by the address. It contains a password, and that can't be null. That's important. The real name could be. We don't necessarily want that. The directory we're going to store the mail in, that can't be null, because otherwise where are you going to put the email? And the timestamp that the user was created, which isn't strictly necessary, but it's useful to know. And by default, it'll just be set to the time we run the command. So we don't actually need to specify that when we create the user. So the key question here is, what are we going to put in the password field? We don't want to store the plain text password. That's a terrible idea. We want to store something that is hashed and hashed securely. We need to make sure that it is hashed in a way that dovecot can cope with, because dovecot is going to receive the login attempt from the user. It's going to hash the password and it's going to see whether it matches what is stored in the database. So we'll install dovecot now, and we can check which hashing algorithms it supports. So we want to run this. Notice that includes some Postgres support for dovecot. You can then run this command with dovadmin to see what it supports for password hashing. Now, the very latest versions of dovecot do support some very strong stuff. They support bcrypt and Argon 2. The version in the Ubuntu repositories doesn't do that yet, but PBKDF2 was the best I could get out of it, so that's what I went with. So if you want to create a hashed password, you run this with dovecot. You specify the schema there, so PBKDF2 in my case. You'll be asked to enter the password twice, and it will then spit out the hashed password. And you want to grab the entire thing, including the bit in curly braces that says PBKDF2, and you need to put that in to the password field when you create a new user. So here we go. We are going to create a user in the table for Octavius with all the relevant data, and that will put him in the system. And if you run a quick select star from users, you can see that that's been added. Now, there are a couple of other things we need to put into Postgres. First of all, we need to tell it about that virtual mailbox thing we want to use. We want to tell it that all mail is going to be handled by a single user and group. So we're going to create a transport table. So here we go. We're only going to need one row from this, so we can put these things straight in. So this entry into the transports table is going to tell Postfix that mail to the example.com domain gets delivered to the group with ID, well in my case 1002. Do swap in whatever your GID for your mail reader Unix user was. And the virtual bit says that this is a virtual transport, and that tells Postfix that this is the final destination of mail sent to example.com. Now finally, we can create, if we want to, what Postfix calls a virtual alias maps lookup table, and that allows us to redirect one email address to another. So if we imagine that Octavius here wants to receive emails to octavius@example.com, but also Octavius the Octopus at example.com, and he wants those directed to the same inbox, we can set that up with this. So again, set up as many of these as you need, but we need the one table and potentially many rows. So here's an example. So we've called the table aliases. Now note which way around the email addresses go here. So the first entry, the alias, is the address of the incoming mail. So in Octavius's case, that would be Octavius the Octopus at example.com, and the email is where we want it to end up, so Octavius at example.com. Now there is something you could do here if you wanted to create a catch-all email address. So you could decide that absolutely any email address, anything sent to something at example.com, should end up in Octavius's mailbox. And you can do that by adding a catch-all where you add an alias that just doesn't have anything before the @ symbol like this. Now the Postfix documentation is full of lots of warnings about this. It is a risky thing to do. If people start sending spam to any old address on your domain, it will all go to your mailbox. You may not want that. If somebody tries to spoof email that looks like it comes from you and it's being rejected by whoever they're trying to spam with it, you may get the replies back in your mailbox, which you don't really want. Now there are some upsides. So imagine that Octavius signs up for an account with Company X, and Company X wants him to give them an email address, because pretty much everybody does these days. He can give them, companyx@example.com, and he can then easily filter his incoming emails. And if company X turns out to be dodgy and they sell his email address to some sort of marketing list, or they just leak it, or they have a breach, then it's easy to tell where the problem lies. You can do this if you want. It is a risky proposition, you know, weigh it up, but this is how you would do it if you wanted to. If you do have a catch-all, then you will also need to add entries for any email addresses that you don't want to be redirected. So if you imagine that Snuffles the Hedgehog here also wants to receive emails, and he wants to receive snuffles@example.com, we need to add an entry in the alias table that redirects snuffles@example.com to itself, like this. Now, although this doesn't really seem to do anything, because it's more specific than the catch-all address, Postfix will use this for anything addressed to Snuffles, and it will end up in his mailbox, and anything that doesn't have an entry in the alias tables will go to Octavius. So the database now has all the information we need in it. There's just one outstanding problem, which is that although the mail reader admin user can access it, the mail reader user can't. So we're going to need to give it select access so it can read from these tables. Now that we can do with these two SQL lines here. So this way the mail reader user can select from the tables, it can read from them, but it can't insert anything, can't change anything, can't delete all the tables or anything like that. And you can try that out if you were to try to add another user to the users table to add an email account as the mail reader user, it would tell you to go away. Okay, we're now going to tell Postfix about all of this. I'm going to suggest that we create 3 new config files within Postfix's config directory, and then we're going to use variables in main.cf to point Postfix to those files. So you may as well, to keep things neat, inside the config directory create a pgsql folder and put the new files in there. First of all, create one called mailboxes.cf, get it looking like this. And so this has all the information Postfix needs to connect to the mail database. It's going to use the mail reader user. It's going to use whatever password you give it. This is where we need to put the plain text mail reader database user password in a text file. And then the rest of it is all about how to generate the query you want it to run. So that table, select field, where field and stuff, that tells Postfix how to construct the SQL statement. So really what we're doing here is we're telling Postfix to run select maildir from users where email equals, you know, Octavius@example.com or whatever the incoming email address is. Now I need 2 other files. First of all, transport.cf. And really this is the same idea, but we're just telling it to run a different query on a different table. So here the query is select transport from transports where domain equals, well, whatever it happens to be, example.com. Finally, aliases.cf. And again, this is just a different SQL statement. Select email from aliases where alias equals, well, whatever it comes in as, Octavius the Octopus at example.com. Now you've done that, go and open up a main.cf and we'll tell Postfix about these things. We're going to add a chunk of things like this. So we're going to start out by making local recipient maps empty. We don't want to deliver mail in the normal way anymore. We're going to use the virtual mailbox system, so we want to turn all that off. We then give Postfix the UID and GID combo for our mail reader Unix user, so swap in whatever values you had for that. We're then telling Postfix where to look for the transport, mailbox and alias mappings. And we pointed to some files, and the pgsql : prefix there tells it that, you know, it should treat the content of those files as instructions on how to read from a Postgres database. There's also virtual mailbox base in there that gets pre-pended to whatever you put in the maildir column for each email address. So that home/mail will get stuck on the front of whatever you put in the user's database, so maybe Octavius/, and that will give us the folder directory that we need for Octavius's email. So reload Postfix's config again, and we should be there. So you should now be able to email any address that exists in the users table or that has an alias defined for it. The /home/mail directory should start out empty, but as mail starts to come in, those folders will be created. So if an email comes in for Snuffles, then home, mail, Snuffles should be created. There'll be 3 folders in there, current, new and temp, and that's where the emails are stored. If you've got any problems with that, you know, do check the mail log, but otherwise we're going to get around to setting up dovecot. But one quick note before we move on about locally generated mail. So services running on your Linux box may try and email root if they run into a problem or something like that. That stuff isn't going to get redirected with all this virtual mailbox stuff, because we're only redirecting using the aliases for anything coming into our domain, which is example.com or whatever it is in your case. Now, if you do want mail, particularly coming to root, to be forwarded to a normal looking email address, probably the easiest way to do that is to set up the .forward file in root's home directory, and that contains a single line. So you can go into /root, create the .forward file and put in a single line of the email address you want that stuff to go to, and that will then get it forwarded, and Postfix will send it on to that regular email address. You can test that out. Just run mail root from the command line, stick stuff in an email, press Control-D when you finish the body to send it, and see if that then ends up in some sort of mailbox somewhere. So we've managed to sort of separate our incoming mail from Unix accounts, but that does mean that it's now even more difficult for us to read it at the moment. We're going to use dovecot to sort that out. We're going to use dovecot to set up something called IMAP, which is going to let us use something like Thunderbird, whatever mail client you fancy, to connect with your computer directly to the mail server and retrieve your emails. So we installed dovecot-imap earlier. That's the thing we need. We just need to configure it. So the dovecot config exists in a couple of places. There's etc dovecot-conf.d, but there's also simply etc dovecot.conf, and we can put our changes in there. So open up dovecot.conf and tell dovecot that we want to use IMAP. We're going to need to change some of the settings that are in conf.d as well. In particular, open up 10-SSL. So first of all, you see there's a line there that says SSL equals yes. That only means that dovecot will accept SSL connections. It won't insist on them. So you can change that to required. We're going to force therefore all connections from mail clients to use TLS encryption. Below that you can see that dovecot is using a couple of self-signed SSL certificates. We could use those, but we may as well use the proper trusted Let's Encrypt ones. Notice the less than symbol at the start of the file name. That tells dovecot to put the content of that file into the parameter and not just to use the name of the file as if it was a parameter. We can also beef up the minimum TLS version that dovecot will accept connections with. Hopefully, if you can insist that people using your mail server use up-to-date clients, you can get away with TLS 1.2. Unfortunately, as I record this, dovecot itself doesn't support TLS 1.3 yet. So you want to find the SSL protocols parameter and set that as tight as you can. So set that to just TLS 1.2, do this. Now, if you're using a newer version of dovecot, version 2.3 or later, you can use the SSL min protocol setting instead. Ubuntu 18 is currently using 2.2. You can also, by the way, look at tightening up the cipher suite that dovecot will use. So even though I'm using dovecot 2.2 on Ubuntu, you can go and find the current sort of recommended standard cipher suite for later versions of dovecot. So what I did was I just pasted in the standard version from dovecot 2.3, which is a bit more restrictive. Now, when I recorded this, you could get the current latest default set of ciphers from here. There's a link in the description as well. And you can also turn on another option called SSL Prefer Server Ciphers, which will mean that the server will use the first cipher in its list that a client supports, even if a client lists a weaker one first. And so because the preference in this list is defined by order. So save that file, and then you can reload dovecot's config. So you can now attempt a local connection to dovecot and see if it's working. So try and run this. If you get a whole splurge of output, including an SSL certificate, then everything is working. The next thing we want to do is we want to get dovecot to talk to Postgres to do authentication, much like we did with Postfix. So open up the particularly snappy etc dovecot-conf.d auth-sql.conf.ext. Now there are two sections here, one for parsedb and one for userdb. Now because we've put all the user info into one table, we don't actually need the userdb stuff, and we can tell dovecot to use just parsedb. Now to do that, go into the userdb section, comment out the two lines that are there and add this one instead. And parsedb you can leave as it is. Okay, now we need to tell dovecot that it should be using the SQL config file rather than the system login config file. So open up 10auth.conf, way down at the bottom, comment out the auth system conf.ext import and uncomment the SQL one, like this. Now, there is a slightly worrying looking setting in that file called auth mechanisms equals plain, which suggests we are sending plain text passwords. That's actually okay. I'm not going to go into all the details here. You can read the blog post if you want to see a bit more about that. But we are going to be sending the password over a TLS encrypted connection, so it's going to be safe there. And dovecot does need the plain password so it can then do the PBKDF2 hashing in order to check whether it lines up with what's in the database. So another file we need to edit, etc dovecot.sql.conf.ext. This is all full of examples, but they're all commented out, so we can add the stuff we need at the bottom. So let's run through these options. Driver equals PGSQL tells dovecot that when we say connect to an SQL database, we mean a Postgres database. The connect parameter tells it exactly how to log in, and here again we're going to need the plain text password for the mail reader user again. Default pass scheme should be whatever you set for your email account passwords, so in my case PBKDF2. And now the password query line there tells dovecot how it's going to get the username, the hash password, the mail directory, and so on. The email as user means we're going to treat the email field as the username. Now we have to hard code that prepended /home/mail/bit here. Dovecot doesn't have a setting for that. and that percentage U bit is a dovecot placeholder. It stands in for the full email address, so octavius@example.com or whatever, and that's what we used in the email field in the users table, so we can safely use that in the where clause. We've also got to tell dovecot about the GID and UID of the mail reader user. It's in another file again. So go to etc dovecot-10-mail.conf. There are 2 entries for this already. You can just uncomment them and stick in the numbers that you need. All right, so save and exit that file. There is one change we probably want to make to Postfix. When you connect to Postfix from your PC or whatever it is you use, there's going to be a received header added to Postfix, which is going to contain your IP address. Not the IP address of your server, the IP address of whatever device you are connecting to your mail server with. And because it's a mail header, it will then go out with any other headers when the email is sent, which means you are broadcasting to the world what your IP address is, and you probably don't want to do that. Now, thankfully, that is easy to fix. We can use Postfix's cleanup service, which runs over all mail just before it gets sent. So open up master.cf and we'll take a poke at that. So you want to find the cleanup service and then just add this at the bottom. Now we're telling it to run a regex that it can find in a file, so we need to create that file, etc postfix header checks, and just stick one line in it that looks like this. And then you can reload Postfix's config. What we've done is we've told Postfix to strip out any received header that contains the with ESMTPSA string. That's going to be what Postfix spits out for your SASL authenticated connection from your mail client, and it's going to have your IP address in it. Now, if you reload dovecot's config again, you should now be able to connect with a mail client, something like Thunderbird, whatever you want to use. Now, if you didn't open up the ports for 587 and 993 earlier in your firewall, you'll need to do that now. And now you also need to configure the mail client. Use the email address as the username, and you want to set to connect with TLS for IMAP and start TLS for submission over SMTP. Again, if you get any problems, do check the logs. Now, dovecot logs by default just straight to syslog, so go into varlog syslog and do a search in there for anything with dovecot in it. Now, once you've managed to connect, you should actually start receiving any test emails you've already sent yourself, because IMAP is going to sync your local mail client's mailbox with what's on the server. However, you might find you've only got an inbox, you've got no sent, you've got no junk or draft or anything like that. In my case, Thunderbird actually creates a deleted folder by itself, and that gets then mapped back onto the server. But you can configure dovecot to create all these things for you. So go back into dovecot, open up 15mailboxes.conf, look for a section that starts with namespace inbox and a curly brace. Now, in here there are lots of folder definitions. You can edit these to mark them to be automatically created and subscribed to. Now, the ones already defined have a special use parameter for some standard behaviors, such as, this is the sent mail folder, that kind of thing. So here's how we ended up after editing. So you can see we've got draft, junk, trash, and sent. Now, if you reload dovecot's config again and get your mail client to refresh folders on your email account, you should see the new ones pop up. However, you're not going to be able to send emails yet, because remember, we decided to insist that Postfix would only accept an incoming mail if it wasn't sent locally, if it was sent with a SASL authenticated connection. So we're going to need to set that up. We're going to need to wire Postfix and dovecot together to make that happen. So we'll do Postfix first, head over to master.cf, find the submission service and add a couple more overrides. So the first of these is just telling Postfix we're using dovecot for SASL, and the private /auth bit is the relative path to a Unix socket that dovecot is going to use to talk to Postfix. By the way, there are probably a bunch of lines still commented out in your submission service. If you want to learn a bit more about those, check out the blog post. However, there is one thing that you might want to turn on in the SMTPD recipient restriction setting, although we're not going to do it here, we're going to do it in main.cf, so it affects everything. So go and open that up. And the one option you want to add here is reject unknown client hostname. In old versions of Postfix before 2.3, that was reject unknown client. It has changed. And it's going to reject any email out of hand that doesn't pass both a forward and reverse DNS lookup check. I'll talk more about that in part 5. You may remember I said earlier, if none of your emails seem to arrive at all, it may be that you're failing this check as well. But this just is a handy spam protection that you might want to set up. Okay, that's the Postfix side. We're now to do the dovecot half of the link up. So find yourself etc dovecot-confd10master.conf and find the service auth section and get it to look like this. Now this gets dovecot to create a socket, a Unix socket. It's a var spool postfix private auth. It's owned by the Postfix user and group. It's accessible only to the Postfix user, and that's going to let Postfix talk to dovecot to do authentication checks. So reload configs on both sides, and you should be able to now send an email from your mail client to the outside world. Now at this point, things are pretty usable. To a certain extent, you could stop here. You know, you can use your mail client, you can send and receive emails, they're scanned for viruses and spam and that kind of thing. But what we're not doing is we're not doing any checks to make sure that email is genuine, that it really is who it claims to be from. And also, we're not taking any steps to make sure that we can pass those checks ourselves. There are things we can do to make sure our emails look less like spam. So there are three areas we want to look at to do with checking mail genuineness. So we're going to use an SPF policy on our end, and we're going to check other people's SPF policies. We're going to start DKIM signing our emails so that it's easy to verify whether or not they really came from our mail server, and we're going to check the signatures of other people. And we're going to set up a DMARC policy, and we're going to check other people's DMARC policies as well. And DMARC kind of builds on top of SPF and DKIM to give us yet another layer of confidence. And also, while we're here, we're going to finally tackle that reverse DNS lookup thing that I've been talking about as well. Now, there's a handy service I was using which lets you check whether your emails are passing basic checks, whether or not they look genuine. It's at verify.port25.com, and that's run by a company which provides mail services, but they have this free checking service. And what you do is you send an email to check-auth at verify.port25.com, and you get a response back which is a report on an analysis of your outgoing email and whether it passes various checks. So if you send an email to them now from your new mail server, you should get back a response that probably looks a little bit like this. So you can see we've got various none and fails. You can see they're using SpamAssassin to check your email, and ham, which hopefully is what you're getting, is the opposite of spam. It means that SpamAssassin thinks your email is legit. However, we don't have any SPF or DKIM checks. That IPRev thing is the reverse DNS lookup stuff I was talking about. You might be failing that as well, and we can look into fixing all of these things one by one. So the reverse DNS checking. So the IPRev stuff works like this. Your mail server connects to someone else's mail server, and it announces that it is sending mail from, for example, mail.example.com. Now, the receiving end goes and looks for the DNS record for mail.example.com, gets the IP address coming out of that, and makes sure that your mail server really is connecting from that IP address. That's the forward lookup. But you can also do what's called a reverse lookup, where you can look up the IP address and you can see what DNS record you get back with a PTR record. So it looks up the IP address and sees if it gets an answer back which says mail.example.com, and this is where things are likely to go wrong. Now, there are lots of different reverse lookup DNS tools. I was using one called mxtoolbox.com, but there are various others. Now, if you put in the IP address of your mail server, you might get a response looking a little bit like this. Where it says domain name, there's a big long string there. It is not very snappy. That's where you want it to say mail.example.com, but it doesn't. Now again, in the blog post, you'll find a bit more information about what that long string is actually talking about, but the key thing is we need to get that changed to point to our mail server. Now that may well not be within your power. You may have to get in touch with a hosting provider and ask them to set up a DNS PTR record pointing to whatever your MX record says, mail.example.com or whatever. Obviously, you may have to wait for them to get around to doing that. Hopefully, it won't take too long. But once that's happened, if you send another email to the check-auth verifier email address, you should find you then pass the IP rev check. So we'll look at the other things we were going to sort out. The easiest one is SPF, which is Sender Policy Framework, and that is a DNS record that tells the rest of the world who is allowed to send email from mail.example.com or from the example.com domain. So when you add an SPF DNS record, you're announcing who's allowed to send email on your behalf from your domain, and if the mail server that's sending the email out isn't that one, then it's easily spotted as a fake. Now, there's no special DNS record type for SPF. You just use a text record, and there are various things you can set in this policy, but a straightforward policy you probably want to use is this. So v equals SPF1, that just flags up that this is your domain's SPF record. Now MX, you could actually put plus MX, the plus is optional, and that means we're announcing to the world that anything that's configured in an MX DNS record for example.com is allowed to send email from example.com, which kind of makes sense. And the minus all says that anybody else can go away. Nobody else is allowed to send email for example.com. So that's a pretty straightforward, pretty robust way of making sure that only our mail server can send email from us, or that appears to come from us. Now, there is a small loophole here, which is that this has no effect on what is in the from header of an email. So by setting the SPF record, no other mail servers can send an email that to another mail server looks like it comes from example.com. That will be rejected. But that doesn't stop someone from spoofing the from field, which is actually what the user will read in their mail client, and making it look like it comes from example.com. We can fix that later with DMARC. We're going to come on to that. But we are at least now preventing mail servers from conning other mail servers into thinking they're allowed to send email from us. So if you now send another email to the check-auth email address, hopefully you'll get back an SPF pass like this. Now, of course, we also want our Postfix installation to be checking incoming mail to see whether it passes the SPF policy framework checks. Now, we're going to need to install some extra stuff for this. We want to run these. This is going to install the Python version of the Postfix policy DSPF system. There is a Perl one as well, but let's not be daft about this. And so we can tell Postfix to use this new plugin to do SPF checking in master.cf. So add the following, create a new service called policyD-SPF, and when it's triggered, it spawns a new process to do this check for us. And Postfix is going to pass it the email, and the process will return the result. Now we can head over to main.cf, we can tell Postfix to use this as the policy checker, and we can add it to the end of the SMTPD recipient restrictions list, like so. And once Postfix's config has been reloaded, you'll be doing SPF checking. And the nice thing about this is the SPF check happens before the email gets passed to Amavis, and SpamAssassin will look at the SPF check result and will factor that into its assessment of whether or not an email is spam. And you can check this is working, so you can send an email to your mail server and out from your mail server. And if you look at the headers when the email is received, you should see something like this: received SPF pass. The next we have DKIM. That stands for Domain Keys Identified Mail. Domain keys is one word. Now, DKIM uses digital signing to provide proof that an email that claims to come from a particular domain really did do so. So we publish the public key for our signature as more DNS records, but we keep the private key private, obviously. So we're the only ones who can sign the email because we have the private key, but anybody can verify the signature because they can access the public key via DNS. And so they can prove that whoever sent the email did have access to the private key, and therefore the email is presumably genuine. Now this is more involved than SPF because we need to generate our public-private key pair, and we need to get Amavis to start signing our emails when they go out. However, Amavis does now do this itself. We used to use something called OpenDMARC to provide this, but it's now integrated into Amavis, so that does save us a step. So first of all, we want to tell Amavis that we want to do DKIM stuff. So head back into 50-user and add the following 2 lines. Now for verifying DKIM keys on incoming mail, that first line turns that on, and that's actually all we need, so that's handy. For signing outgoing mail, there's more to do, so that second line tells Amavis that we want to do it, but we need to tell it how to do so. And so for that, we need to add another line like this. So what we're doing here is we're telling Amavis where to find a DKIM key to use to sign emails. That's the last argument there in that line. The first argument says which domain's emails we want to be signed, and the middle bit is a selector that gets sent out with the DKIM signature in the outgoing email, and that tells the recipient how to find the DNS record that has the public key in it, so it can then verify the signature on the other end. It doesn't actually matter what that selector is, so that selector there, which is just the date in January when I did this, that tells the receiving end of any of my emails it needs to look for a DNS record that is called 2020-0129 _domainkey.example.com, and that will contain the public key that it needs to use. So we're going to create a directory inside the Etsy Amavis directory to contain the keys, and then we can tell Amavis to make a DKIM key for us, which is quite handy. So here we go. So we make a directory, switch in, generate the key. The chown means that the Amavis user can read the key. We don't want just anyone on the machine looking at it. It is a private signing key. And if you then reload Amavis, you can then get it to spit out the public key part that you need to put in your DNS record, like this. So you've got to turn that into a DNS text record. The host part needs to be set to, well, in this case, whatever the selector is. So in this case, 2020-0129._domainkey.example.com. And the value needs to be set to everything inside the brackets, starting with the v equals DKIM 1 bit, and all of the p equals bit. It's very long, but put it all in. After the v equals DKIM semicolon bit, I would also add h equals SHA256 semicolon, k equals RSA semicolon. That's just to be explicit about what kind of key it is. The receiving end can probably work it out, but we may as well be clear. Now, once you've added that as a DNS record via your hosting provider, do check that the entire key is present. I have in the past run into problems with hosting providers where they were truncating a DNS record to a maximum length and you only had half the key, which of course doesn't work. We now need to make one very important change to our Postfix and Amavis setup. So currently we are sending all email that arrives at Postfix to Amavis on one port, 10,024, comes back on 10,025, and that means that ingoing and outgoing mail are being treated the same, but we now need to start treating them differently. For outgoing mail, we want to add our DKIM signature to it before it goes out. For incoming mail, we need to make sure that the DKIM signature, if there is one on the incoming mail, does pass. Now, the easiest way to do this is to get Amavis to listen on 2 ports, and we'll send incoming mail on to 1 port and outgoing mail to the other port, and they'll then get resubmitted back to Postfix again on 2 different ports, so they can be handled differently. So first of all, we want to get Amavis to listen on 2 ports. So open up 50-user again. We're going to override something in one of the other defaults files and add this. And so here we're just asking it to listen on 2 different ports. While we're here, do set max servers to 4 rather than 2. We're going to have 2 Postfix services that are sending to Amavis, and we're going to set max prop to 2 for both of them, so we need 4 in total. So now I need to head back to master.cf. We need to create a second service for send to Amavis. We're going to update the first one slightly to make the name clearer. So find your LMTP Amavis service and change it to look like this. So here we go, they have the same properties, they just have different names so we can talk to them separately, and we've labelled one as incoming and one as outgoing. And now we need to direct the incoming and outgoing mail to those 2 different services. So go and find your submission service and add an override for the content filter to send it to port 10,026 like this. And then in main.cf you want to change the default content filter to point to the new service name for the incoming one. So for now we are still sending all the email coming back from Amavis back to port 10,025. We'll change that later, but we can leave it for now. The next thing to do is to get Amavis to actually start signing emails. So go back to 50-user in the Amavis config and add this lot. So there are 3 parts to this. So we're telling Amavis first of all that anything that comes in on socket 10,026 should be subject to the originating policy. Now that name is just a convention. Calling it originating by itself doesn't give it any special power. We then define a policy bank block that defines the originating policy. And here we set the Amavis originating flag in lowercase to 1. Now this does have a special meaning because Amavis knows that if DKIM signing is on, anything that has the originating flag set to 1 should be DKIM signed before the email goes out. Now this is where we run into that bug I've been talking about in an old version of Amavis, in the version that's in the Bionic repository. So if we had that version running, setting originating equals 1 wouldn't do anything, and we wouldn't be DKIM signing our emails. And as that comment notes, we're going to force a 7-bit character encoding before we sign, so that if some other mail server somewhere else insists on a 7-byte format, it's not going to change it after we sign the email, which would break the signature. And we have this DKIM signature options by sender maps. That tells Amavis how to sign mail based on where it's coming from. So by setting the source to that dot, we're telling Amavis to use what follows to sign all mail, and then everything else tells it how. So we tell it to use an RSA SHA-256 algorithm. Because we've only set 1 DKIM key, Amavis will find it and will use it. Now this C equals relaxed thing, that tells Amavis how to canonicalize the email before it sends it. Now there are 2 options here. You've got simple and relaxed. The problem with simple is that if new lines get added or removed to an email in transit, that will invalidate the signature. Relaxed gets us around that problem because we never quite know what another email server might do to our email. It's safer to do that because then we don't find that an email gets fudged somewhere and the signature fails even though it shouldn't. In fact, if you look at an email you get from somewhere like Gmail, you'll find that their policy is relaxed/relaxed. The reason we have relaxed/relaxed is that one refers to the email headers and one refers to the body, but we'll keep them the same. And now that TTL field, that's time to live, that says how long the signature should be considered to be valid for. Now it's in seconds, so 21 times 24 times 3600 is 21 days. That's fairly arbitrary, but any email we send really ought to arrive by then. And if anything arrives with a signature that's older than that, it should be rejected. So when you're rotating your DKIM keys, you should make sure you leave the old key up for as long as it's time to live, so that if an email does arrive that should be considered valid, it can be verified because the receiver can get the public key. So reload Postfix and Amavis, and if you then send another email to the check auth verifier thing, you should find you're passing DKIM checks as well. The other thing you want to do is you want to send an email to your mail server that you know will have been DKIM signed. Anything from one of the big providers like Gmail will do that. And you can look in the headers having received it, and you should find something like this. There'll be authentication results header, and there'll be some DKIM fields in it, and hopefully it'll tell you that it's passed. Okay, we're now to the final section. We're going to look at DMARC. That is the domain-based message authentication, reporting, and conformance system, which is, not that snappy, but there it is. And it builds on top of SPF and DKIM. So we said before that SPF stops mail servers sending email that claims to come from us if they're not allowed to, but it doesn't prevent them spoofing the from field, and with DMARC we can deal with that problem. So DMARC insists that the email has to pass either an SPF check or DKIM check, or both, and that the from field, the domain in there, has to match either the SPF or DKIM domain. Now to support DMARC for outgoing mail, all we need to do is add a DMARC DNS record to our DNS setup. So the DMARC record tells receiving mail servers that we have DMARC in place. We want them to run a DMARC check. We tell them also there what to do if the email fails. The options are don't do anything, treat it as spam, or just ditch it. And we can also there put in an email address that we want other mail servers to talk to give us reports on how things are going, if they're rejecting things or whether things are passing, and so on. That means you can, if you want to, you can announce a DMARC policy that says don't do anything, don't change what you're going to do with an email if you fail DMARC, but do send me emails about it, and you can use that just when you're initially setting up your DMARC setup to make sure that everything seems to be working before you start telling other mail servers to start throwing emails away if they fail checks. By the way, Google has a very good article about this. I'm going to put the link in the description. Do check that out, and they've got a good way of implementing DMARC over time and scaling up the severity of the action you take, or you want other people to take if DMARC fails. So this is going to be another DNS text record. The name just needs to be _DMARC dot, well, whatever your domain is. And the value should be something like this. So let me talk you through that. So the v equals DMARC1, that just marks this as a DMARC record, that's required. The P field is also required. That's where we say what to do if the DMARC check fails. This can be none, it can be quarantine, which means treat it as spam, or it can be reject, which will throw it away. There's also an optional SP field, which you can use to configure mail coming from subdomains if you want that to be different. Now, a DKIM and a SPF control the alignment mode for the checks. The default is R, that's for relaxed, and that means the mail must come from the domain in the SPF or DKIM check or any valid subdomain, whereas S is strict, which means the domains must match exactly. Now, if you're not sending email from subdomains, you can safely use that. RUA is an optional field that enables aggregate reporting. So you're saying to any receiving mail server that has any failures and so on, that you want to receive an aggregated report probably once a day. You can specify it as well. There are more options for that. That you want to receive a report saying, what failures you had and what the server did about them. And you specify the email address there. The mail2: is required. You can comma separate the addresses if you want it to go to more than one place. There is also RUF, which is for forensic reports, and by putting an email address in there, you are asking a receiving mail server, if it has a failure, to immediately email you a forensic report about the failure in real time. But that is a risky thing to do, partly because if someone is spoofing email from your domain and they're failing the DMARC checks, you're going to get a lot of forensic reports about that, and that could be more than the amount of legitimate email you actually receive. And secondly, the forensic report you receive could actually contain anything up to an entire copy of the email that was sent out. And that means you could then be receiving to your forensic report mailbox personally identifiable information about other people, which you then need to deal with in a responsible way, and it'd be easier to not have to deal with that. And in fact, because there are privacy concerns about the forensic reporting, lots of email providers actually now refuse to send out forensic reports anyway. So if I were you, I would not specify this. I would leave that alone, but do consider aggregate reports if you want to know how your DMARC compliance is working. And there's another optional argument, which is PCT, which is the percentage of emails to take action on if the DMARC check fails. So by default it's 100, but you could set it to something like 5 when you change the action in P, so you can check that things seem to be working before you suddenly start telling other people to throw away 100% of emails because you've got some config wrong on your side. Again, look in that Google article, they have recommendations on how to ramp that up over time. Okay, so you're now DMARC compliant on the outgoing end, but you're not doing any DMARC checks on incoming mail. We can sort that out. And for that, we're going to use a bit of software called OpenDMARC. Unfortunately, this is going to mean making our postfix setup a bit more complicated. So currently, we have 2 ports we use to send to Amavis for incoming and outgoing mail, but they're all coming back on one resubmission port. We are going to now need to split that out. We're going to need to run OpenDMARC as a mail filter. We're going to need to run it after Amavis has had a look at the email, because Amavis is what's doing the DKIM check. But we only want to run OpenDMARC on incoming mail, not an outgoing mail. So we need to add it as a mail filter on a resubmission port that is separate to one that's handling outgoing mail. However, the new service we need is very similar to the one we already have. So go into master.cf on the postfix side and add a new service there. So note the port number there. It means that incoming mail is being handled on port 10,024 and comes back on 10,025, and outgoing mail is handled by 10,026 and comes back on 10,027. It doesn't really matter, but it's just a bit neater that way. Okay, we then need to go back to the Amavis side. We need to go back to 50-user. We need to go and find our originating policy bank and tell it that it needs to resubmit to postfix on a different port, like this. Okay, now before you actually do anything else, before you go and add OpenDMARC, reload Postfix and Amavis configs and make sure that mail is still working in both directions. Once that's all working, we want to grab OpenDMARC, and it puts this config directly into /etc/opendmarc.conf, so open that up. Now for the Ubuntu installation, most of the defaults are going to do, but there are some things we want to change. So we want to get OpenDMARC to put its listening socket in more or less the same place as Amavis does. We also need to add a list of hosts that we want OpenDMARC to skip. Now, we don't actually want it to skip any, we want this to be an empty list, but if we don't specify one at all, OpenDMARC will skip all mail coming from localhost. But because OpenDMARC is seeing the mail after it's been resubmitted by Amavis, that's where all the mail has come from, and so if we're not careful, it won't check anything at all. So put the socket in var spool postfix OpenDMARC OpenDMARC.sock. Ignore hosts, takes a file name, so put that in there, and then we'll go and make sure that file actually exists. We need to make the directory and then just touch the file. Okay, now go to var spool postfix and we're going to create a directory for that socket to go in. And we're also then going to use that chown. That means that the OpenDMARC daemon can create the socket, and then adding postfix to the OpenDMARC group means that postfix can access it as well. So we now need to tell postfix about the mail filter, but only to use it on port 10,028. So go back into master.cf. Put the socket in the SMTPD milters override on the 10,025 resubmission port, like this. You also need to go to the receive override options line and remove the no milters entry, otherwise SMTPD milters is going to be ignored. Okay, so restart OpenDMARC and postfix and you should be away. Now if you send this off an email from a service that has posted a DMARC record and go and check the authentication headers, you should see something like this. Okay, so you can see that OpenDMARC is scanning the emails, and you can see it's putting a header in to say, well, this is the result. But what it won't do at this point is it won't actually ever take any action against an email that fails the alignment check. It won't apply the policy that the controller of the domain has set. Now to turn that on, you need to use the frankly rather oddly named and horrendously documented option, reject failures. You need to set that to true. Now, given its name and the way it is documented in the config file, you might think that it would simply throw away any email that fails the alignment check, regardless of the policy of the controlling domain. However, it does just do, what you'd hope it would. It does just allow through anything that has a p equals none, even if it fails. It will quarantine, p equals quarantine, it will reject, p equals reject. So this is the option you want, despite the fact that it really doesn't look like it. So turn that on and you are then applying the DMARC policy set by the controller of the domain that an email you receive claims to come from. If you want to send failure reports, then there are two options you want to set. You want to turn failure reports to true, and you can also then set the email address that the failure reports will appear to come from when they go out from your server. That's failure reports sent by. By default, OpenDMARC will use user sbin sendermail to send that out. If you want to change the command it uses, there is a report command option you can update as well. You might find here and there online documentation about a forensic reports option that would do stuff for the RUF fields if they're set in the DMARC policy rather than just the aggregate RUA fields. However, those seem to have been retired. If you try and put that into your config file, it will OpenDMARC will just fail to start as it would with any other unknown config. So it seems those have been disabled. One last thing for OpenDMARC, by default it doesn't run itself on startup. You need to set it up to run as a service with system control. And there you go. You have a working mail server. You can send and receive emails. You can use a mail client to do that. You're sending emails where possible over TLS. You're checking for spam. You're checking for viruses. You're verifying signatures. You're sending your emails out with an SPF policy and with a DKIM signature and so on, so they can be flagged as legit. And you have a pretty solid mail server. So I hope that between this video and the blog posts, I've got you to where you need to be. If you've got any questions, do hit me up in the comments and I'll see what I can do. But thank you and goodbye.